Show with me, Joe. It's Technology Tuesday, which means we read an article that has to do with technology. But this week's article is more like Science Tuesday because it's entitled 5 Lesser Known States of Matter That May Shape the Future. And we know that the future is shaped by technology, but that also involves science. So I thought, let's read this article because it sounds super interesting. Plus, it's presented in a pretty cool way. From Inverse.com, we've got the 5 lesser known states of matter that may shape the future. I'm sure you're familiar with a couple states of matter, but we'll get to it. Let's see what's going on. From an early age, like kindergarten, we're taught that liquid, solid, and gas are the states of matter. There's also plasma. I don't know why they didn't mention that, but yes, solid, liquid, and gas. This couldn't be further from the truth. Solid, liquid, gas, and plasma simply represent the 4 most common, quote, natural states of matter. Whether or not they appear solid, wet, or wispy, come on, wispy, we know that's just gas, depends on movement of their internal particles as a result of external factors like heat. Because we interact with these states most often, it makes sense that they're the most well-known, kind of like a popularity contest. In the background image, we also see the different states of matter at a molecular level. So in solid form, you can see that they're very organized and not moving, or not moving much. In a liquid form, they're starting to bounce around and be a little bit more fluid, liquid. And then in the gas form, we can see that the molecules are very spread out and also moving around a lot. And in the plasma form, it's even more, and it seems to be heated because there's red ones, and they're moving around like crazy and chaos. That atomic movement is also why it's so hot, is because it's moving so fast. So scientists have found and created even wilder states of matter. Now, I'm going to tell you right now, these states of matter are definitely so wild, you would love to party with them. These rare or man-made states of matter can help us understand things far beyond our own lives and can help scientists and us understand everything from star formations, I'm an Aries, to quantum computing, which is an upcoming form of computing that uses quantum mechanics and quantum bits. So let's find out what these forms of matter are. It matters to me that you like my content, so hit that subscribe button and mash that bell so you get a notification every time I upload a new video. Thank you. We've got the BoseEinstein Condensate, BEC. It's what forms on cool beverages like you see here. That's some BoseEinstein concentrate condensate. It also tastes good. That's not what it is at all. This is a state of matter that can be credited to both Indian physicists Satyendra Nath Bose and Albert Einstein. Borrowing from Bose's math, Einstein proposed to Satyendra. Just kidding. Einstein proposed the existence of this new and super cool state of matter in 1924. It was later experimentally verified in 1995. It seems like it is kind of like plasma. It's on the other side where it's super cooled. In laboratories, this state of matter can be found at extremely low temperatures and is the result of particles huddling together to form a super atom, which sounds like a superhero. I am Super Atom, and I'm here to destroy Eve. No, I don't think that's how that works. A super atom without molecular motion. Scientists can create this state in a lab and use it to study quantum mechanics and black holes. That would be the BoseEinstein Condensate. Next up, we've got a laser light show. Did you know that when you go to EDM shows, you're actually experiencing another state of matter? You're not. Quark, gluon, plasma, seen here. This is an incredibly energetic state of matter, a soupy mix of plasma quarks. Let me try that again. A soupy mix of quarks, which are the mini atomic particles that make up protons and neurons, and the gluons, or the glue that holds quarks together. This was a state of the universe right after the Big Bang. Sounds like a dope party. Like, look at that. Laser show! I need to get some QGP up in my EDM show. I'm going to drop some quark glue on plasma in my dubstep. You know what I mean, guys? Next up, we've got Degenerate Matter. Degenerate Matter. I'm a degenerate matter. Sometimes. Here, degenerate refers to a state of matter that's just under a lot of pressure. Dude, degenerates are under a lot of pressure. Like they have both no expectations and everything expected of them, those degenerates. He gets so much pressure to succeed or to not succeed. Degenerate matter, it's found at the core of stars. I mean, that's pretty cool. And occurs when gas inside the core becomes so compressed that its source of pressure transforms from thermal energy to quantum energy. And then it becomes degenerate matter. Dude, hey! Quit hanging out in the core of the star and get a job, man! Degenerate matter. Next up, we've got superconductivity. Superconductors are really cool because they can produce very low to almost no cost energy. Unlike some of the more theoretical states of matter, you might actually be lucky enough to get a demonstration of superconducting materials at your local college physics lab. These materials are super cooled, and as a result, they win all the popularity contests. And as a result, they offer zero resistance to electricity, meaning they're an extremely good electronic conductor. These materials are also impervious to magnetic fields. In real life, they can be used to make everything from super fast levitating trains to super cooled and fast electronic circuits for quantum computing. Also, if we can find a room temperature superconductor, that is like the holy grail, because the closest they can get now is, I think, like negative 100 degrees. To be a superconductor, but if we can have a room temperature one, that means we can have the power of superconductivity right in our living room. Well, maybe not right in our living room, but in normal everyday life, which would be transformative. Next up, we've got something called time crystals. Isn't that what Thanos was trying to get? The time crystal? Also called space-time crystal. We are talking about infinity stones. This theoretical state of matter is a pretty recent addition to the group. It was proposed in 2012 by MIT professor and Nobel Prize winning I thought that said Nobel Prize winning physicist. Nobel Prize winning physicist Frank Wilczek. Buckle up, because things are about to get timey-wimey. And I'm not talking about Doctor Who. Whoa! What do we just enter Willy Wonka's tunnel? This is crazy time crystal. Traveling through time. Crystals, like diamonds, are a girl's best friend. No, they're prized for repeating geometric patterns that don't change much over time. Time crystals, however, change in both space and time, meaning the entire crystal changes from moment to moment. Mind blown. Controlling these crystals could mean that you're Thanos, or it could mean it's the key to mastering, quote, warm quantum computing above absolute zero. Currently, quantum computing must need to be in the state of absolute zero so that the quantum bits can move. But if we could control time crystals, then we can master warm quantum computing. And this is the goal for the future. This is the technology that we're looking for so that we can travel through time. Not sure that's how that works at all. Lastly, we've got one other theoretical state of matter, very new, very cool, and that is information. There's a guy who's proposing that information and data bits are actually another state of matter, and that we may be facing a data catastrophe because we are building so much data that it could actually cause weight on Earth and cause a catastrophe. We're not going to read about it today. Maybe we'll read about it on next week's Tech Tuesday, because that's been this week's Tech Tuesday. If you like my content, hit that subscribe button and mash that bell so you get a notification every time I upload a new video. And I hope that you learned something good this week, because there's so much education in this video. We learned about superconductors. We learned about quark soup. We learned about degenerate matters that are just living in the core of their parent stars and not getting jobs. And we learned about the BoseEinstein particles. And then we learned all about the time crystals so that we can be Thanos. How rad. So that's today's Joe Show. Come back next week. Until then, read something good and email it to hijoeshow@gmail.com, because, you know it, I tech you.